But we know it goes through the point, -4, -5, perpendicular to this line. What does perpendicular mean? It crosses and makes a right angle. So if it's going to be perpendicular, what do I need to find first? The slope. So we get y by itself. Subtract over our x. It's -2y. It's -x plus 6. Divide everything by -2. So it's like a -1 divided by -2, so we get 1/2 x minus 3. Now the only thing I'm getting from this is my slope information. This line has a slope of 1/2. If it is perpendicular, what will my new slope be? Close. Right, you have to flip it and change the sign. So if it was positive, it becomes negative. If it was negative, it becomes positive. So two things, flip, change the sign. So now I have my slope and I have this point. So we can plug into our equation. So y minus the y value, so minus -5, equals our slope, -2, times x minus our x value, -4. Biggest mistake I'm seeing right now, when you have minus and negative, what does that become? Right. Those are positive. So we get y plus 5 equals, if I distribute, that would be a -2x. -2 times 4 is -8. Subtract over our 5, so our final equation is -2x minus 13. Any questions there? What if I said it was parallel to f of x equals 4 and going through the point 3,5? That's a little bit different. What does parallel tell me? Same slope, right? But this isn't written in y equals mx plus b. F of x is the same thing as y. This is just y equals 4. What does a y equal 4 look like? It's a horizontal line of 4. So remember, f of x is the same thing as y. If it's just y equals a number, you have a horizontal line. What is the slope of a horizontal line? So my slope is 0. And it's going through the point 3,5. So y minus our y value equals m times x minus our x value. So y minus 5 equals 0, y equals 5. Could you look at that horizontal line and tell me domain and range of it? What would my domain be? Negative infinity, positive infinity. What is the range of that? 4. We only hit the one y value. Any questions there? What if we had done a line perpendicular to that? What kind of line is perpendicular to a parallel or to a horizontal line? Yep, the vertical line, the slope undefined. So it'd be x equals a number. So if it's going through this point, it would have to be x equals 3. All right. Any questions about those writing equations? Okay, we should also be able to graph our lines and give domain, range, and slope. I kind of practiced that there, but let's do a couple more. If I want to graph this, what should I do first? We need our slope, so add over the 2x. Divide everything by 3. So y is 2/3 x plus 4/3. So if I want to graph that, start at your y-intercept, which is 4/3. Slope is 2/3, so that means you go up 2 and over 3. What's the domain of that? What's my range? What's my slope? 2 over 3. You don't include the x with it. Slope is just the number. What about b? What's different there? There's no y. So let's get the x by itself. So x is negative 7/3. If you have x equals a number, what does that graph look like? Vertical line. We did a y equals just a second ago, right? That was horizontal. X equals is a vertical line. Negative 7/3. So it's negative 2. What's my domain of that one? Negative 7/3. What is the range? What is the slope of a vertical line? Alright, so that's all things lines. Writing equations, graphing, domain and range, parallel, perpendicular. Any questions about our lines? Okay, let's do some review problems for our older stuff. Can you look at a graph and tell me if it's a function? Yes, what are you looking for? Vertical line test. So is this one a function? Yes. What would be my domain? Domain, remember, is left to right. Because this keeps going, it keeps getting wider. What would be my range? And since we hit 0, it gets a bracket. If this had had like endpoints here instead of arrows, what would my domain have been? My range would be 0 to 4, yeah, and my domain would be negative 2 to positive 2. So you just have to watch if it has the arrows and keeps going or not. All right, so could you look at a graph, decide if it's a function? Give me domain and range. Domain left to right, range up and down. Always interval notation for that stuff. If I ask you to find from my graph f of negative 2, remember function notation, that's f of x. It's saying x is negative 2. Or if x is negative 2, find your y. So if I go to that graph, when my x is negative 2, I'm here. What's my y value? 4. Okay, if I said f of 1, what would that equal? 1. When x is 1, y is 1. If I said f of negative 1, what's that equal? Negative 1. Not negative 1. When the x is negative 1, the y is still positive 1. Okay, so you can evaluate functions from our graphs. Along that function notation, let's say I gave you the equation. F of x is negative 6 minus 2x. If I ask you to find f of negative 1, what am I asking you to do? Sub it in. So that would be negative 6 minus 2 times negative 1. Negative 6 plus 2 is negative 4. I don't have to give you a number. If I said f of b minus 5, I'm still just subbing it in. Whatever is inside this parenthesis replaces the x in the equation. So it's going to be negative 6 minus 2 times the b minus 5. This is like a negative 2, so if you distribute that, you get a negative 2b plus 10. Add like terms, so 4 minus 2b. So it doesn't have to just be a number. You could get another expression involving variables. So we did that. when we talked about our functions. Any questions there? Kind of working backwards, our newest to oldest stuff. If I give you 2 points and I want the distance between them, I put the formula on the board. Remember, each ordered pair has an x and a y. That's x in the first, y in the first. X in the second, y in the second. So our distance formula, the square root of x2 minus x1 squared plus y2 minus y1, so minus negative 1 squared. So negative 6 plus negative 5 gives me a negative 11. 2 minus negative 1, so 2 plus 1 is 3. Negative 11 squared is 121. 3 squared is 9. I get the square root of 1/3. What should you always verify at this point? If anything will go into it. This one is not divisible by any perfect square, so that would be my answer. But if it was, you do have to break it down. A midpoint. So that's on the board. You add your x's divided by 2, add your y's divided by 2. So x1 is 5 plus x2 is negative 6 divided by 2. y1 is negative 1 plus y2 is 2 divided by 2. So if I do that, we get a negative 1/2 and a positive 1/2. Just something we're here. 1/2. Reduce if possible. If it were like 6/2, go ahead and tell me it's 3. Any questions about distance and midpoint? Pythagorean theorem, be prepared to draw a triangle on those. So if I said a triangle has a hypotenuse, if it has a hypotenuse, that tells me it's a right triangle. Hypotenuse is the longest side across from my right angle, that's 20. One of these legs is 16. Find the other one. A squared plus b squared equals c squared. Okay, what's 16 squared? 20 squared. So if we subtract over our 256, we get, if it doesn't work out perfectly, you can have a radical still. Just make sure reduce if possible. Any questions there? Really, the only other thing we did was talk about going back and forth from like set notation to interval notation. So if I gave you something like this, can you write the interval to go with that? If you need to, draw yourself a number line. This is saying x is between 0 and 6. Equal to, not equal to. In interval notation, what do we use for an equal to?
Oh, a line
bracket. Yeah, here the equal to is the line under it. For the interval, we go to bracket. And if it's not equal to, it gets a parenthesis. If you had one, if I just said x was greater than or equal to 1. Okay, equal to tells me close circle. Greater than, what would that interval notation be? 1 comma infinity. Infinity always gets parentheses. If it had been less than, going the other direction, what would it have been? Negative infinity to 1. You always go left to right, small to large. So we did talk about that as well when we were working on our interval notation, being able to go back and forth. Do you guys have any questions for me? Okay. So let's spread out. You need a pencil and a non-graphing calculator, please.